Hello, welcome back. Welcome back. I'm John, an old YouTuber and PC gamer. It's Saturday evening and all this X86 video there public. I like to continue, but I have to look this X86 document on the Wikipedia because I have to download more, like the MMX 3D now. I have to download some of this, but I have to try to stay on my lists. So let's open the PDF again. But let's get, that's the X86 assembly language. But let's get some lemonades. The sun is going down, it's 8:30 p.m. But that was nice, good to get started again today with this computer project, because that's more than 3 weeks ago, that's too long time. That's because I did start to play GTA 5 and I record like 300 video Dennis. I was walking around the map 2 times, this big island in GTA 5. I was walking around there 2 times, just for fun and recording Dennis. Then it was end of month, then I start to build some Lego. I got some boxes with Lego, so I made many Lego videos in Danish and English. I like to have this Lego bricks should be a part of my YouTube channel. I still got 2 boxes of Lego. No, that's the Lego I talk about. I got these boxes. Got this dinosaurs and got a car. So I did build that on English, but you can build 3, that's 3 in one set, you can build 3 different. So that's the dinosaurs. And I built a small one, and this one, Lego Ninjago. Now this is 3-to-1, you can build 3 different kind of models. This one was a little bit less, $50, that's a houseboat. Actually, I would like to buy one more so I can build this. Then I like to build a buy a blue building plate like this. I could have a small dog with a house and small. That's for Lego City. Yes, that's my tiny Lego collection. So I don't have much Lego. But because every time I build my Lego is inside models. And I built this car, got this for free. I was building this too on the video. So this is why I did this 3 weeks. So that was one I built a long time ago just for fun. I spent a lot of Lego bricks. Yes, but let's continue. But that will be the final one for today. It's 9:30. I think we have power enough for the camcorder. Yes, and I should. That's 16 pages, but many of the pages is this references. So I have to keep my fingers away from the mouse button, because if I by mistake I'm clicking, the auto read will stop. So I have to I used to have my fingers on my left mouse button, but I cannot do that. But let's start to read the whole document.
X86 assembly language. X86 assembly language is the name for the family of assembly languages which provide some level of backward compatibility with CPUs back to the Intel 8008 microprocessor, which was launched in April 1972. 1.2. It is used to produce object code for the X86 class of processors. Regarded as a programming language, assembly is machine-specific and low-level. Like all assembly languages, X86 assembly uses mnemonics to represent fundamental CPU instructions, or machine code. 3. Assembly languages are most often used for detailed and time-critical applications such as small real-time embedded systems, operating system kernels, and device drivers, but can also be used for other applications, such as the game Roller Coaster Tycoon, 99% of which was written in X86 assembly. 4. A compiler will sometimes produce assembly code as an intermediate step when translating a high-level program into machine code. Contents: mnemonics and opcodes, syntax, registers, segmented addressing, execution modes, switching modes. Examples: instruction types, stack instructions, integer ALU instructions, floating point instructions, SIMD instructions, memory instructions, program flow. Examples: Hello World, program for DOS in MARSM style assembly. Hello World, program for Windows in MARSM style assembly. Hello World, program for Windows in NASM style assembly. Hello World, program for Linux in NASM style assembly. Hello World, program for Linux in NASM style assembly using the C standard library. Hello World, program for 64-bit mode Linux in NASM style assembly. Using the flags register. Using the instruction pointer register. See also. References. Further reading manuals. Books. Mnemonics and opcodes. Each X86 assembly instruction is represented by a mnemonic which, often combined with one or more operands, translates to one or more bytes called an opcode. The NOP instruction translates to 0x90, for instance, and the HLT instruction translates to 0xF4. 3. There are potential opcodes with no documented mnemonic which different processors may interpret differently, making a program using them behave inconsistently or even generate an exception on some processors. These opcodes often turn up in code writing competitions as a way to make the code smaller, faster, more elegant, or just show off the author's prowess. Syntax. X86 assembly language has two main syntax branches, Intel syntax and AT&T syntax. 5. Intel syntax is dominant in the DOS and Windows world, and AT&T syntax is dominant in the Unix world, since Unix was created at AT&T Bell Labs. 6. Here is a summary of the main differences between Intel syntax and AT&T syntax at Untitled parameter des hours before the destination. Move for $5. %x. Destination before source. Move x. 5. Parameterized mnemonics are suffixed with a letter indicating the size of the operands. Q for word, L for long word, W for word, and for byte. 5. ADL $4. %ESP. Derived from the name of the register that is used, E.G.Rax, X, AX, AL imply Q, L, W, B, respectively. .ADSP, 4. Sigils immediate values prefixed with a $registers prefixed with a %. 5. The assembler automatically detects the type of symbols, i.e., whether they are registers, constants, or something else. Effective addresses general syntax of DISP, base index scale. Example: move for mem_location, %x, %x4, %x. Arithmetic expressions in square brackets, Additionally, size keywords like byte, word, or word have to be used if the size cannot be determined from the operands. 5. Example move x and x*4 plus mem_location. Many x86 assemblers use Intel syntax, including NASM, FASM, MASM, TASM, and YASM. GAS, which originally used AT&T syntax, has supported both syntaxes since version 2.10 via the .intel_syntax directive. 5.7.8. A quirk in the AT&T syntax for x86 is that x87 operands are reversed, an inherited bug from the original AT&T assembler. 9. The AT&T syntax is nearly universal to all other architectures with the same move order. It was originally a syntax for PDP-11 assembly. The Intel syntax is specific to the x86 architecture, and is the one used in the x86 platform's documentation. Registers. x86 processors have a collection of registers available to be used as stores for binary data. Collectively, their data and address registers are called the general registers. Each register has a special purpose in addition to what they can all do. 3. AX multiply / divide, string load and store. BX index register for move. CX count for string operations and shifts. DX port address for in and out. SP points to top of the stack. BP points to base of the stack frame. SI points to a source in stream operations. DI points to a destination in stream operations. Along with the general registers, there are additionally the IP instruction pointer. Flags. Segment registers, CS, DS, S, FS, GS, SS, which determine where a 64K segment starts. No FS and GS in 80,286 and earlier. Extra extension registers, MMX, 3D now, SSE, etc. Pentium and later only. The IP register points to the memory offset of the next instruction in the code segment. It points to the first bit of the instruction. The IP register cannot be accessed by the programmer directly. The x86 registers can be used by using the MOV instructions. For example, in Intel syntax MOVX 1234H copies the value 1234 hex 4660D into register AX. Move BX AX copies the value of the AX register into the BX register. Segmented addressing. The x86 architecture in real and virtual 8086 mode uses a process known as segmentation to address memory, not the flat memory model used in many other environments. Segmentation involves composing a memory address from two parts, a segment and an offset. The segment points to the beginning of a 64 KB, 64 to 10 group of addresses, and the offset determines how far from this beginning address the desired address is. In segmented addressing, two registers are required for a complete memory address. One to hold T segment, the other to hold the offset. In order to translate back into a flat address, the segment value is shifted 4 bits left, equivalent to multiplication by 24 or 16. Then added to the offset to form the full address, which allows breaking the 64K barrier through clever choice of addresses, though it makes programming considerably more complex. In real mode / protected only, for example, if DS contains the hexadecimal number 0xDEAD and DEC contains the number 0xCAFE, they would together point to the memory address 0xDEAD *0x10 plus 0xCAFE equals 0xEB5CE. Therefore, the CPU can address up to 1,048,576 bytes, 1 megabyte, in real mode. By combining segment and offset values we find a 20-bit address. The original IBM PC restricted programs to 640 kilobytes, but an expanded memory specification was used to implement a bank switching scheme that fell out of use when later operating systems, such as Windows, used the larger address ranges of newer processors and implemented their own virtual memory schemes. Protected mode, starting with the Intel 80286, was utilized by OS/2. Several shortcomings, such as the inability to access the BIOS and the inability to switch back to real mode without resetting the processor, prevented widespread usage. 10. The 80286 was also still limited to addressing memory in 16-bit segments, meaning only 216 bytes, 64 kilobytes, could be accessed at a time. To access the extended functionality of 80286, the operating system would set the processor into protected mode, enabling 24-bit addressing and thus 224 bytes of memory, 16 megabytes. In protected mode, the segment selector can be broken down into 3 parts: a 13-bit index, a table indicator bit that determines whether the entry is in the GDT or LDT, and a 2-bit requested privilege level. See X86 memory segmentation. When referring to an address with a segment and an offset, the notation of segment offset is used. So in the above example, the flat address 0xEB5CE can be written as 0xDEAD0xCAFE, or as a segment and offset register pair, DS:DX. There are some special combinations of segment registers and general registers that point to important addresses. CSIP. CS is code segment, IP is instruction pointer, points to the address where the processor will fetch the next byte of code. SSSP. SS is stack segment, SP is stack pointer, points to the address of the top of the stack, i.e. the most recently pushed byte. DSSI. DS is data segment, SI is source index, is often used to point to string data that is about to be copied to SDI. SDI. S is extra segment, DI is destination index, is typically used to point to the destination for a string copy, as mentioned above. The Intel 80386 featured 3 operating modes: real mode, protected mode and virtual mode. The protected mode, which debuted in the 80286, was extended to allow the 80386 to address up to 4 GB of memory. The all-new Virtual 8086 mode, VM86, made it possible to run one or more real mode programs in a protected environment which largely emulated real mode, though some programs were not compatible, typically as a result of memory addressing tricks or using unspecified opcodes. The 32-bit flat memory model of the 80386's extended protected mode may be the most important feature change for the X86 processor family until AMD released X86-64 in 2003, as it helped drive large-scale adoption of Windows 3.1, which relied on protected mode, since Windows could now run many applications at once, including DOS applications, by using virtual memory and simple multitasking. Execution modes. The X86 processors support 5 modes of operation for X86 code: real mode, protected mode, long mode, virtual 86 mode, and system management mode, in which some instructions are available and others are not. A 16-bit subset of instructions is available on the 16-bit X86 processors, which are the 8086, 8088, 80186, 80188, and 80286. These instructions are available in real mode on all X86 processors, and in 16-bit protected mode, 80286 onwards, Additional instructions relating to protected mode are available. On 80,386 and later, 32-bit instructions, including later extensions, are also available in all modes.